battery like this both provides and removes energy. It provides energy because it has an EMF, electromotive force. There are chemicals inside this battery which undergo a chemical reaction to separate charges from one another so that you get a positive and negative terminal. But inside the battery, there is also resistance, and that removes some energy, making the battery hot. That resistance is called battery internal resistance. In this practical, we want to determine what the battery internal resistance is of this particular battery. First, we need to cover some theory and understand what battery internal resistance is and how we can calculate it. This is a symbol of a battery. However, to help us to think about battery internal resistance, let's rather draw the battery like this. In other words, let's include the battery internal resistance, which we don't normally put in the symbol of a battery. So we can see that the battery has two parts: an energy supplying part and an energy removing part. When the battery is not connected in a circuit, then no current can flow through the battery. Then we can ignore the internal resistance because it doesn't remove any energy when no current flows. But if we connect this battery into a circuit like this, then current is going to flow through the circuit. And as it does, it also flows through the battery itself. And that results in the battery internal resistance removing some of the energy, some of the voltage, some of the energy per charge. So the EMF puts voltage into the circuit, forcing the charges to move around the circuit. And as the charges move through the load, they remove some of the voltage which the battery had given to the charges. And as the charges move through the internal resistance of the battery, the internal resistance also removes some of the voltage. And the total voltage which the external and internal resistances remove is equal to the voltage which the battery puts in, the EMF. That's one way to view it. Otherwise, if you like, you could say that the total voltage which the cell gives could be called V in, and that equals V out, which is the voltage removed by the external circuit. But for this video, let's take EMF as what we could call V in. EMF puts voltage in to the circuit, and any resistor, whether it's the external or the internal resistor, takes voltage out. In the other videos, we actually view it rather as V cells is V in. But for this movie, let's view it in this way. We know that voltage is equal to current strength multiplied by resistance, IR. So the amount of voltage which the internal resistance removes is equal to IR, where I is the current strength flowing through the battery and R is the value of the internal resistance in ohms. And that's the value that we're trying to find out. So it's important to realize that the internal resistance is measured in ohms, but the voltage that it removes, which we call V internal resistance, is measured in volts. They're not the same thing. The internal resistance R is a resistance, whereas V internal resistance is a voltage. Now, V internal resistance is because of internal resistance, but they're not the same thing as one another. V internal resistance is how much voltage the battery removes from the circuit because of the internal resistance. And you can calculate how much that is by multiplying the current strength through that internal resistance by the internal resistance, I small r. But you cannot go and actually measure this value, V internal resistance. You can't put a voltmeter just across the battery internal resistance. Why not? Well, you can't get inside the battery to do that. And anyway, how would you separate just the resistor? I mean, we draw it as if it's separate like this, but it's actually throughout the battery that you have this resistance. So it's impossible to go and actually measure the internal resistance directly. Similarly, it's impossible to go and measure internal resistance with an ohm meter or something directly. So these we can only calculate. So let's now look at what we can measure. One thing we can measure is V cells, terminal potential difference. Terminal potential difference is the potential difference reading you'll get on your voltmeter when you place the voltmeter across a battery when current is flowing through the battery. In other words, when the battery is part of a complete circuit. And can you see that that value, V cells, will be the same value as V load? V load means the potential difference you'll read on your voltmeter when you place the voltmeter across the external resistance, also called the load. And can you see that V cells and V load will read exactly the same as one another? We can see that these two connection points are actually connected to one another, and these two connection points are actually connected to one another by good conductors, and therefore the two voltmeters measure the potential difference across the same parts of the circuit, in fact. So their readings will be the same. V load measures how much voltage the external resistance removes from the charges as they move through it. You can go and measure V load with a voltmeter placed across the external resistance, or you can calculate it as I big R. That big R stands for the load. In other words, by multiplying the current strength through that resistor by the resistance of that resistor of the load. So as you can see, we can do various calculations using the current strength through the circuit. But how do we know the current strength through the circuit? We use an ammeter. Ammeter must be connected in series in the circuit, and it will tell us the current strength flowing through the circuit. And since this is a series circuit, that ammeter reading will tell us the current strength flowing through every part of the circuit, through the battery, through the external resistance, through, of course, the internal resistance as well. Now, what is the relationship between these various types of voltage that we have here? EMF is one kind of voltage, V internal resistance is another, and V load, which is the same thing as V cells, is another. How are these three related to one another? Remember that the voltage that a battery puts in is equal to the voltage that a circuit takes out. Now, if we view the internal resistance as part of the circuit, then we include what the internal resistance takes out in here. That's what we're going to do for this movie. So there are two things which take voltage out: the external circuit, V load, and the internal resistance. And the amount of voltage that it takes out is V internal resistance. So if we add these two voltages together, then we're getting the total amount of voltage that comes out of the circuit. And that is equal to the voltage that the active ingredient in the battery puts in. In other words, that the EMF puts in. So here we have our formula. EMF is equal to V load plus V internal resistance. And just remember, V load is V cells, so it could also be EMF is equal to V cells plus V internal resistance. And since we can calculate voltage by current strength times resistance, we can rewrite this equation in this form. V load is I capital R. In other words, the current strength flowing through the circuit multiplied by the load, the resistance of the load. And V internal resistance is I small r. In other words, the current strength flowing through the circuit multiplied by the internal resistance of the battery, small r. So EMF is equal to I capital R plus I small r. And we're going to use this formula to solve for what little r is, to find out what the value of the battery internal resistance is for this particular battery.